Alright, so we will finish the practice test right now, starting with number 21. So number 21 is continuing more with writing equations of lines. We have to write an equation that's parallel to the line given right there. So first of all, we need to know that parallel lines have the same slope. So our new line is going to also have this same slope of negative 9 over 5. But we don't know what the y-intercept is. We know what it is for this line, but that's not the line they're asking us to find. They're asking us to find a totally different line. So how do we find the y-intercept, the b value? Well, they tell us that this goes through 0, 4. Okay, so you could actually plug in 0 for x and 4 for y, or to save yourself some time, you can recognize something. If I plot the point 0, 4, it's right here, and that is the y-intercept, because the y-intercept occurs when x equals 0. Notice all along this axis right here, every point on the y-axis, x is equal to 0. So if you do plug in 0 for x and 4 for y, you end up getting v equals 4. So that should be our answer right there, negative 9/5 x plus 4. Alright, 22 and 23, same thing, same idea, I should say. The only difference is now we're dealing with perpendicular lines. So we need to find a line that is perpendicular to this one, and we need to know that perpendicular lines have slopes which are negative reciprocals. So what does that mean? Well, first of all, the reciprocal of this, the reciprocal of 4 over 7 is 7 over 4. And the negative reciprocal, well, the negative of a negative would be a positive. So it's going to be positive 7 over 4x. And again, we don't know b. This b, this 2 right here, is a totally different line. That's the line. The only reason we needed that line is to find this slope right here. But we're not allowed to use their y-intercept because that's a different line. Okay, our line is going to go through this point. So that's an x-coordinate, that's a y-coordinate. So I'm going to plug in the negative 5 for y. That's this one. And then I'm going to plug in the negative 4 for x, because they tell us that that point is on that line. Now we multiply 4 goes into itself once, and it goes into that negative 1 times. 7 times negative 1 gives us negative 7. So this is negative 7 plus b, which is negative 5. We're going to add 7 to both sides so we can get b by itself. And negative 5 plus 7 is equal to 2. So that means b is equal to 2. So this right here is the final equation for our line, y equals 7/4 x plus 2. Okay, 23 is the same thing. We want to find a line that is perpendicular to this one, which means the slope is going to be the negative reciprocal of 1/2. The reciprocal of 1 over 2 is 2 over 1, and the negative reciprocal is negative 2 over 1. We don't need to write 2 over 1 because 2 over 1 is just 2, so we just write 2. Again, we don't know what the b is, so we will try to find that right now by plugging in negative 1 for y and plugging in negative 2 for x. And solving, negative 2 times negative 2 is 4. And then if we subtract 4 from both sides, negative 1 minus 4 gives us b is equal to negative 5. So that means this number right here should be plus b would be plus negative 5 or minus 5. And that's the line that is perpendicular, as you can see. Alright, 24 and 25 ask us to graph absolute values, and the easiest way to do this, we really only need 3 points. An absolute value graph looks like this. We need this point right here, that's the vertex. Okay, and that occurs when the thing inside here is equal to 0. So that's how we're going to find the vertex. We need the thing inside the absolute value equals 0, and then we need a point on either side. And once we have that, we can easily calculate the rest. Alright, so how do we find the vertex? Remember, we only need 3 points. The vertex goes in the middle. The way that we find the vertex is we're going to set this thing equal to 0, because that's where the vertex occurs. And then we'll solve it. So we'll subtract 2 from both sides. Negative 3x equals negative 2. Divide by negative 3. And that means x is equal to negative 2 over negative 3, which is the same as 2/3. Okay, then we should pick a number just above it and a number just below it. And notice in the parentheses we're going to be taking the x and multiplying it by negative 3. So I want to travel the same distance. And I want to have something over 3 because that's going to cancel with that negative 3. So let's just go up 1/3. And if you go up 1/3 from 2/3, you'd have 3/3. 3/3 is just 1 though. So let me erase that and I'll put a 1. And then we want to go the same distance. We want to have gone up 1/3 to get to 2/3, and that means we started at 1/3, because 1/3 plus 1/3 is 2/3. Okay, now to find the y's, all we need to do is plug these things in. So I'm going to plug in -3 times 2/3 plus 2. And by the way, these things are absolute values, just to make that clear. Okay, so those will cancel, and we'll have -1 times 2, which is -2 plus 2. And we already said that that's 0. So the absolute value of 0, which is 0 plus 2, that equals 2. So we have the point 2/3, comma 2 on our graph. 2/3 is a little bit less than 1, so maybe about right here, and then there's our vertex. By the way, if the thing in front of the absolute value were negative, not the thing inside, but the thing in front, so -3 is negative, but that's not what it affects. If the number in front of the absolute value is negative, this will point down. Okay, but in most cases, it's going to point up. It's going to be positive like it is right here. And then let's find the other ones right here. So if we plug in 1 for x right here, and we solve this out, -3 times 1 is -3 plus 2 would be -1. And the absolute value of -1 is 1. 1 plus 2 is equal to 3. And this will actually be 3 also, because if you look at this absolute value graph, it's symmetrical. The y's are the same on both sides. This one and this one are the same. So if we find one of these correctly, we know the other is automatically 3. So I'm going to graph the point 1, comma 3, puts us right here, and then 1/3, comma 3 puts us here. And there's our graph. Like I said, we only need 3 points, and we have them right there. All right, let's do the same thing on 25. We'll make a table of values right here. So first thing we always want to do is start by finding the vertex, which means when does this thing equal 0? So we'll set it equal to 0. We will subtract 3 from both sides. We solve for x by dividing by 2. So there is the value of the vertex. And -3/2, that's the same as -1.5. Okay, so now let's plug this in. And we already know that this whole thing is going to be 0. That's how we found it in the first place. So 0 minus 3 would be -3. So the point -1.5, -3 on the graph is right here. Okay. This will still open up, because notice that number in front, that's just a 1 in front there. It's still positive, so it's going to open up. And then let's pick a number bigger and smaller. So smaller than -1.5 would be -2. Bigger would be -1. Notice that I went the same distance. I went up 0.5 each time. That's important in order to get the symmetrical y value showing up. So let's plug these numbers in right here and see what we end up with. 2 times -2 is -4. -4 plus 3 is -1. So that's the absolute value of -1 minus 3. Absolute value of -1 is 1, and 1 minus 3 is -2. So that means this is also -2. So -2 is right here, and -1, -2 is right here. And there's our graph. We said it should point up, and it does. Alright, 26 is a piecewise function, and it's called a piecewise function because it has 3 pieces. You can see this one, and this one. So what we need to do is graph 2 points. A line needs 2 points for each part in the line. So let's start by getting 2 points from here. And one of the points for x should involve this number. So I'm going to put in -1. How do I find the y value? I just plug in -1 right there. So we have -1 plus 2. -1 is 1, and 1 plus 2 is 3. Okay, and then secondly, if you look at this condition, I need x values that are less than -1. So my second point should be any x that's less than -1, and I'll just pick -2. Okay, then same thing, I'm going to plug in -2 right here. So -2 is +2, and plus this 2 right here. +2 plus 2 would be +4. So let's graph these 2 points. So -2, 4 puts us right here, and -1, 3 puts us right here. Now why did I not shade in that circle, that dot that I just put in? Because this right here says x is less than -1, not less than or equal to, but only less than. So that means there's only one possible way. It never actually equals -1, so we don't need to shade that in. And then I'm just going to connect the dots like this. Sometimes people ask, how do I know to draw to the right or the left? Well, that unshaded, or that circle there that doesn't have a shading, that's the cutoff point, that's the boundary. This says x is less than -1, so we don't want to shade over here, because that's places where x is greater than -1. Alright, so let's do the second piece now. Again, it's called a piecewise function. we're going to need 2 points here. And actually, this one's easy. They give us both of our points for x, -1 and 4. If x is in between an inequality like that, just use the 2 points on the other side. Up here, we use -1 because that's the only number they gave us. Okay, down here, we're going to end up using +4 as one of our points. Okay, then we get the y's by plugging them in. So -1, if I plug in -1 there, -1 minus 4 is -5. And if I plug in 4 here, 4 minus 4 equals 0. So I'm going to graph those 2 points. And notice both of these are less than or equal to. So if it's less than or equal to, I'm going to shade in those points, -1, -5. And I will also shade in the point 4, 0, because x can be less than or equal to those. So there's our second piece of the graph. Third piece of the graph is here. Again, we need 2 points. One of them they give to us. One of them is 4. And then I need x's that are greater than 4. And so I'll pick 5 because 5 is greater than 4. Now notice there isn't any place to plug in x. The only number there is -1. Y equals, that's what f of x means. F of x means y equals this. So there's no place to plug in. What does y equal? It equals -1. There's nothing else to plug in. So 5 -1 puts us here. And 4 -1, notice that x is greater than 4. It's not equal to. So 4 -1 should be unshaded, and it's right here. And then I connect those, and that's what the graph should look like. So let's double check. And there it is. Actually, I'm sorry, I forgot to. X is greater than 4, so it should be going this way. But otherwise, I think ours agrees with what they have. All right, transformations. So there's 4 types of transformations that you can have, and I'll make a simple example here. Let's say this is called a parent function, by the way. It's the graph that all parabolas are based on, and then right underneath it, next to it, I'll do this. I'll do -2 x plus 3 squared minus 4. Okay, so here's what each of these things do. This number right here tells us if it's going to go right or left, and the way that you tell, there's a saying, add to x, go left, and this number here tells us up or down. And the saying for remembering that is, oops, let me use a different color just to keep these consistent here. This one is up or down, that number, and the way that you tell is with this kind of saying, add to y, go high. So if you're adding a number right there, you go up. We're subtracting a number, so we're going to go down. Okay, this number in front right here tells us if it's going to vertically stretch or shrink. And if it's bigger than 1, you stretch it. If it's smaller than 1, you shrink it. That number 2 is bigger than 1, so it would be a stretch. And then finally, this number here tells us we are going to reflect it over the x-axis, because we're taking this entire function, this whole y value, and we're making it negative. If you look on a graph, here's a graph. The y values are positive up here. If I suddenly make them negative, they're down here. And I just reflect it over that axis. That's the x-axis. So let's apply that reasoning to each of these. So first of all, this negative right here, we just said is going to reflect it across the x-axis, so this one might be possible. This one has nothing to do with reflecting. This one might be possible, that one might be possible, because we're reflecting. This right here, now notice the difference between this right here versus this right here. Okay, they do look similar, they both have a -1. What's the difference? In this one, the -1 is attached to the x, so that means you're moving in the x direction. That's right and left. Okay. This one right here, the -1 is attached to this entire function value, this y value. So you're moving up or down. So in our problem, the -1 is not inside the parentheses. It's not like this one. So the -1 is going to move in the up or down. And the saying is add to y, go high. We are subtracting from y, so we're going to go low. We're going to go down 1, which is this one right here. This one does not mean go up, but it doesn't mean go left either. All right, 28 is the next one. So nothing is happening on a right or left basis. This number is going to vertically stretch it by 2. If the number is bigger, another name for stretch, by the way, is expand. Okay, vertically expand by a factor of 2. Now here's the problem though. Most of these say horizontally. So if you vertically stretch something out, like what happens is horizontally it kind of compresses, and you can kind of visualize that. If you think of like a slinky or something, if you have a slinky that's balled up and you pull it or you stretch it out, it's going to horizontally shrink in its width. Okay, so not only are we vertically stretching it, we're compressing it or shrinking it horizontally. So we're going to write both of those because they might ask us. So expand horizontally is wrong. We said it's compressing. This one might be possible.
expand vertically, that's the same as compressing horizontally. That might be possible. This is wrong, though, because we're not expanding vertically. And then finally, the -3. Notice the difference between this right here and this right here. This one is a right or left 3. It turns out to be right 3, because add to x, go left, we're subtracting from x. This one is taking the whole function, the y value, y equals the absolute value of x, and it's subtracting 3. Add to y, go high, we're subtracting from y, so we're going down 3. Now, even though we were stuck between C and B, this one doesn't say down 3. This one does, so it must be B. All right, the last two are sketching graphs of inequality. So sketching a graph of inequality, there's the easiest way to do it is probably change it into slope-intercept form, which means let's subtract 3x from both sides. So we're left with negative 5y, and that is greater than or equal to negative 3x minus 10, and then we want it to be y equals mx plus b. Right now it's negative 5y, so we'll divide by negative 5. The only thing to remember here is when you multiply or divide by a negative number, this sign has to change direction. So it's going to be y is less than or equal to negative over negative becomes positive 3 over 5x, and negative 10 over negative 5 is positive 2. So this has a y-intercept of 2, so that one is wrong because that's not a y-intercept of 2. Neither is this one. But both C and D have a y-intercept of 2. And then this says move up 3 over 5. So this one looks like if we go up 3, we go to 5, we go over 5, that works. This one means go up 3 over 5 too. So how do we tell the difference? This is less than or equal to, so the shading should be below the line, which is like, see, this one right here, you're shading above, so that would be y is greater than or equal to. The other thing is because it's equal to, the line should be solid, which this one is, but that one is not. That has a dotted line. Okay, this one is done the same way. We'll put it again in slope-intercept form by subtracting x, so we'll have negative y greater than or equal to negative x plus 1. Divide by negative 1 on this side, and we'll get y. Remember, we divided by a negative, so that has to change direction. Negative over negative is positive 1x, and 1 over negative 1 is minus 1. So that we're looking for a solid line, because that's y is less than or equal to. These are not solid, so actually the only one that works is C. Now let's verify. This has a y-intercept of negative 1, which is right here. The slope is actually 1. It's 1 over 1. So go up 1 over 1. Solid line, and this means y is less than, so that means shade below. So you can see that right there. So hopefully that helps. That's the Chapter 2 practice test, and all 30 problems are there.